first speaker, Miss Nobetsiki. She is no stranger to FGL. We have the pleasure of having her join us just before the start of your preliminary exams. She is a maths buff, if you can say, somebody who loves the language so much. She's a mathematics educator at Cowan High School, started teaching 11 years ago, and has since taught grade 12 for the past 5 years. She holds a Bachelor of Education from the Walter Sisulu University and has been a marker for maths papers, a provincial and district moderator for mathematics, focusing on grades 12, paper 1 and paper 2. And she's going to start her discussion on that prep exams. Ms. Luleka Nobetsiki, good afternoon. Welcome to FGL. So excited to have you back.
Afternoon, FGLers. It's exciting to be back. As hectic as my schedule is during this time of the year, like it's bad, it's so bad, it's so bad, but I couldn't miss out on an opportunity to come here and actually discuss what we actually went through the past few weeks, like the Friday the 9th, as well as or the Friday the 6th of April and the Monday of the 9th of September. So I am here not to talk this time, but to engage with the grade 12s to see what actually happened in that exam room. So it's good to be back, guys. Thank you so much, Olutu.
I'm going to hand the floor over to you. Grade 12s, please remember your questions that you submitted to with Sandile or Ms. Nobetsiki will be going through them. But if you have any other questions as she's going through the presentation, there's moments through her presentation where she'll allow you to ask some questions and you can engage. Well, over to you, ma'am. Let's have a great session.
Thank you so much. Afternoon, guys. I thought that I would have my question papers with me, the hard copies, but unfortunately, I only have a soft copy that is now on my cell phone. So do forgive me if I glance away from the screen a bit. So in the start of my presentation, I just wanted to at first unpack what happened in paper 1. Wow, paper 1 was such a lenient paper. I had a talk with a few of the examiners that I know that were part of examining the September prelim for paper 1. And I actually commended them on boosting learners' confidence when it comes to the standard of the paper, because there is nothing as frustrating as getting into an exam. Someone has practiced for as long as they could remember, but when it came to the actual paper, the person just, the information flashed out. So the paper was quite good. Even my lowest of them lowest in the class managed to pull through. So that's one of the reasons I said the paper was quite lenient. But today is not about the lenience of the paper or how hard it was to answer some questions, but it's just on the misconceptions. As I was making the paper 1 grade 12s from my school, what are the common mistakes that learners tend to make when it came to the paper? Question 1 was quite straightforward. Question 1 was quite straightforward from 1.1 up to 1.2. And then the trick started in 1.3. We all know most in that section of 1.3, that's whereby we get to discuss the nature of roots and everything. So we got to this question, and I hope people have their question papers or something. We got to this question, and the question says, you are given f of x as x squared plus 3x, and you are told that 2x minus into bigger brackets, t of x to the power of 1 and over 2 is equal to 0. Now they're saying that for which values of k? That's a question that we always get in that last question, because one of the things that we need to expect when it comes to the last question in question 1 is we will either be making relations when it comes to exponents, so exponential equations, as well as the nature of roots. So whenever a person gets to that last question of question 1, it's whereby we get to think the whole questions were for anyone and everyone. But now when it comes to the last question of the paper, the cognitive level changes. So now we look at that question 1.3, and it is said that the roots there have to be equal. What does that statement alone, just that statement, the roots have to be equal? So we know that whenever we're talking about the nature of roots, it's b squared minus 4ac from grade 11. So in grade 11, we said that we have got about 4 nature of roots, whereby we say the roots are real, rational, and equal. That means b squared minus 4ac is equal to 0. And then you have got your b squared minus 4ac is greater or equal to 0. That is whereby we say now the roots are real, rational, or irrational, and then they are unequal. Then we get to have the fourth one, because the rational and irrational, they serve as 2. And then we get to now to have the fourth one. The fourth one, we said that the roots are non-real. So learners need to understand that when you are answering that question, everything depends on you creating a standard form of an equation. That is your b squared, your ax squared plus bx plus c. You need to have your x squared as your first term. You need to have something with the x as your middle term. And whatever it is that does not have x and x squared, it belongs as to the last term as your value of c. So learners tend to make a mistake whereby when we are asked about the nature of roots, they simply take whatever equation. So the first goal we need to know is that you cannot have your b squared minus 4ac in a haphazard equation. I said the first term must have an x squared in it. That represents the value of a. The second term must have x in it. That represents the value of b. And the last term is a constant. It does not have x, it does not have x squared. Then we are able to identify the nature of roots. So what we were supposed to do in that question 1.3 is to first create an equation that is in a form of a trinomial. That is, you must have your ax squared plus bx plus c. So we get now to question 2. Next slide, Butluvuko. We get now to question 2, whereby in question 2 we were doing the sequences in series.
FGLers, please remember to have your microphones on mute until we ask you to engage in terms of the Q&A. Sorry, Ms. Nobetsiki.
Okay, I was just about to ask. Yeah, thank you. So now we're getting to the sequences and series. As well there, learners were flowing on these questions, just as I've said. Now with the 2.1.3, learners got to stuck there a bit, because there is one thing about mathematics that is the worst of them all, whereby you go there memorizing the method on how things are done. We don't do that in mathematics. You cannot, I usually make this reference of doctors. If I come in having a knee problem, and someone who's 55 comes in having a knee problem, and you as a grade 12 learner, 16, 17-year-olds coming in having a knee problem, we cannot be diagnosed with the same thing and be given the same treatment. Probably you fell, that is why your knee is giving you trouble. Someone who is 50 years old is lacking with collagen. So now the treatment that you are going to give to those people is totally different. So where am I getting with this? learners tend to observe how they did certain calculations on a particular question and assume that a question that looks similar is supposed to be answered in a similar way. It looks similar. It is not the same. And remember, when we're talking about similarity and congruency, when two things are similar, it doesn't mean that they are the same. It's just that there are certain features that makes these two things to be similar. But when we're discussing congruency, we're now referring to two things that are exactly the same. So what happened with that 2.1.3 was that it said a product of two consecutive terms, a product of two consecutive terms within the first difference. It's a product of two consecutive terms within the first difference. And we know that in the first difference, the standard equation of a first difference is Tn is equal to a plus into n minus 1 into d. So all you had to do, because you already have the sequence for the first difference, you just had to determine the general term. So the general term meant that you are now multiplying 2n minus 1 times 2n minus 1 is equal to that 1,153, if I'm not mistaken. But now learners used the method that we always use, whereby we said the difference between two consecutive terms. Difference between two consecutive terms means that we are subtracting. But this time it said the product. Remember, product goes with multiplication, difference goes with subtraction, sum goes with addition, and a quotient goes with division. So in 2.1.3, a lot of learners missed that, but a few of them actually got it. 2.3, what is it about 2.3? Learners struggled with 2.3 when it comes to the interpretation of the question. I'll just check quickly. Okay, it said there, the sum of the first three terms of an increasing, the sum of the first three terms of an increasing arithmetic series is 30. So T1 plus T2 plus T3 is equal to 30. It's an increasing arithmetic series. And then it says that the product of the same three terms is 510. Product goes with multiplication. At first, we said the sum, that means it's T1 plus T2 plus T3. But now we are saying the product is the same. It means that it's going to be. Okay, I hear some people talking.
Yes, FGLers, I'm going to ask that you please make sure that you have your microphones on mute. We have such limited time to go through all the papers. We'd like to limit interruptions as less as interacting with Ms. Nobetsiki.
Okay, let me not take much time as well, because I can see that time is going to be against us. The next thing it says was that the same pattern or the same three terms now have a product. That means we're now saying T1 multiplied by T2 multiplied by T3 is going to be equal to 510. Let me remind you something, FGLers. When we're talking about sequences and series, if I say term one is a formula. What is the formula for term one? Term one is equal to A. If I say term two, what type of a sequence am I talking about when I'm saying term two? I'm talking about an arithmetic sequence. So if ever I'm talking about an arithmetic sequence and I'm mentioning term two, it means that term two is actually A plus D. Term 3, it's A plus 2D. Same goes for the geometric. In geometric, term 1 is still A. Term 2, it's A multiplied by R. Term 3, it's A multiplied by R squared. So one of the things that we go there and we tend to not, we take for granted, if I could say, is that each term in the pattern has a formula. It just doesn't end with having the general term as Tn is equal to A plus n minus 1 into D, or the general term for geometric as A times R to the power n minus 1, which is something else that we get to see even at the marking center. When a learner is told about a sum of a geometric series, they use the general term of a geometric series. Once your n, it's a minus 1, it means that now you are doing a general pattern. When we are doing a sum, the sum has no n minus 1 when it comes to the formula. So please pay attention to that. I have a lot of learners who had the time of their lives with the paper because the paper was quite easy. But the mistakes that they made, when I come back and show them you are 130 out of 150, the person is frustrated at the fact that what are the things that he actually missed. So those are the things that we need to pay attention to. 3.2, I said here in 3.2, when determining the value of m, yes, here's another thing. You have a sigma notation, and the sigma notation expects you to determine the number of terms. That is the value of m that we have written on top of your sigma. A learner knows all the calculations. Remember, when you see a sigma notation, the first thing that you think of, your first mark comes from creating the first 3 terms, because we will want to mark the value of term 1. So even if you don't know how to proceed with your sigma notation, do at least get that mark of expanding your sigma notation. Because once you have expanded your sigma notation, the first thing that you need to look out for is that what is the relationship between these terms? Because there can only be 2 relations. It's either it's arithmetic or it's geometric. If T3 minus T2 is not T2 minus T1, then trust me, T3 over T2 is going to be T2 over T1. So first thing we do when we see a sigma notation, we expand. So what learners did there was that they determined the value of n using basic algebra. After determining the value of m, it's not the answer that we are looking for. When you have m there written, we want to know the number of terms. If k is equal to 3, that's what it says at the bottom. K is equal to 3. So when you're starting your calculations, the learners are calculating and are getting an answer that is 12. But now our k starts at 3. So if k starts at 3, remember that the formula is top minus bottom plus 1 is equal to the value of m. So when you got the top part as 12, you needed to subtract the bottom, which was 3, if I'm not mistaken, and then add 1 to that so that you could actually have the number of terms. So whenever we are doing our calculations, let us not forget to answer the question. Next slide, Butluvuko. Functions. Okay. Learners were able to answer question 4. Yes. We had the time of our lives. We were given the hyperbola. Learners were able to do the asymptotes. It was so nice. It was so nice. But one of the things that excitement, I hate it when my kids get excited when it comes to maths. I always dim people's lights. I'm bad like that. I don't want a person getting to an exam excited, because the mistakes that learners tend to make out of excitement are ridiculous, and you hate yourself afterwards. So I was saying to them, this is the last time that I am marking your scripts. So I don't know who's Mr. Van der Merwe will be marking you in December, but I need you to write for them. When you're writing this, I need you to write for them. A person has identified the asymptotes. X is equal to -5, Y is equal to 2. But when it comes to plotting the asymptotes, the person now swaps values. Instead of having a vertical asymptote as -5, -5 now becomes a horizontal asymptote, meaning that the person is excited at the fact that, damn, I know this thing. So the minute you get to have those emotions, breathe in, breathe out, breathe in, breathe out, and then everything else will be cool. So never be excited. And then it said, the axis of symmetry with the gradient of -1. Remember that we've got 2 equations on the axis of symmetry. We've got the one that has got a positive gradient, and we've got the one that has a negative gradient. So the fact that they said it is a gradient of -1, in mathematics, they always hide things right in front of us. Like someone could just say, fine, Miss Nobetsiki, right now, I'm just in front of you. But because you did not expect that a person could be like telling you to find someone who is in front of you, you would think that you have to go and look It doesn't work like that. So now you've got this -1. This -1 literally means that you have your equation as y is equal to negative, open your brackets, x plus c, to show that this one is an axis of symmetry with a negative gradient. How do you determine the value of c? You take your asymptotes. The horizontal asymptote goes to the value of y, the vertical asymptote goes to the value x, and then you factorize the brackets out, then you solve for c. Then that is it. So it says now in question 5, when we're talking about the equation of the axis of symmetry, what was in question 5? Let me just go check quickly. In question 5, it said there, determine the equation of the axis of symmetry. We always emphasize this, that when a question says equation, it's like being asked in hyperbola, because you are plotting in September, you are not going to plot in November. In November, you will be given a hyperbolic function and you'll be expected to do the interpretations. So in your interpretations, you'll be expected to determine the equations of the asymptote. The word equation should remind you that we've got two values or variables in mathematics. We've got x and we've got y. So when we say determine an equation, we mean that x is equal to or y is equal to. But then the equation of the axis of symmetry is referring to the value of x. So it is the x value of the turning point. So you were supposed to say x is equal to minus b divided by 2a, in which all of that information, you will find it in your standard equation of a parabola. Now, the question there that a couple of learners turned to me was that question in 5.3, which said, determine the maximum length of PQ. Whenever we are dealing with the parabola, and there is a question that has something to do with maximum, a maximum in a parabola is the value of y. It is the turning point of y. So whenever we're talking about the maximum value, it means that we have to look at the value of the turning point of y. So if you look at your graph, the maximum distance that we're going to get in that function, because it is a straight line combined with a parabolic function. So the maximum distance that we're going to get there was from the turning point, because it is at the lowest part of our parabola. So the lowest part of our parabola joined with the straight line. So whenever we are calculating the distance between two functions, distance is calculated through subtraction. So we had to subtract the parabola and then subtract it from the straight line, because the parabola, according to that graph, is below the straight line. So now it means that it's going to be y is equal to mx plus c minus the equation of the parabola, and then we solve for x. We're talking about y. It's the y values that we're referring to there. So the y values that we're referring to there, the first part, one thing that I would love to mention is that mathematics is sequential. So there's a reason as to why the first question will say determine the axis of symmetry. And then the second question that comes after says calculate the length between, because they know that for you to be able to calculate the length between, you need to use that value of x that you got as the axis of symmetry to substitute in your straight line so that you could be able to find the y value. Remember, the vertical distance is merely talking about the y-axis. It's a vertical line. So it's the distance, it's the maximum distance in y of the parabola and distance of y on the straight line function. Now let's get to the part whereby it says any g of prime or f of prime notation is referring to the gradient of a line. We had a debate with quite a few educators when it comes to that. Remember, you will never be asked such a question in grade 10. The G's of prime and the F's of primes are asked in grade 12 because they know that these learners have been doing calculus. So if ever you have been doing calculus, you know that this is a first derivative. And what do we call the first derivative? We say that it is the gradient of the tangent. So the gradient of the tangent tells us that the slope of the curve is either negative or positive. So whenever the question says on the last part, it said, determine UG of prime of x multiplied by f of x, where the values of x will be less than 0. Sifuna values zika x apho, the y value of f multiplied by the gradient of g will give us a negative number. When we look now at the slope of, when we look now at the slope that we got on that function of the straight line, that slope represents a positive gradient throughout. And then when we look at the parabola, we were not told to determine g of prime of x, which is going to be the gradient again, the gradient of g, but we're to just look at the part. If ever the slope of f is a positive slope, now let us look at the part whereby our f of x is on the negative side, because when we're saying a number must be less than 0. The number that is less than 0 means that you are multiplying two unlike signs. That is, it's a positive that is multiplied by the negative sign. Then we are to get a number that is negative. So when it comes to those g of prime, I wish I had shown that part. When it comes to those g of prime and the f's of prime, always remember that it is talking about the slope, that is the gradient of the tangent. Because if ever we have a function as the gradient of the tangent, unless it is a straight line, because a straight line is already a straight line. Thank you. Then can we go to the next slide? Next slide. I had a question from the FGLers where I think someone asked, how do you, I cannot recall it clearly. I will see it at the end of this. They were talking about changing, I think, from log to an exponential form. In mathematics, if you are given x is equal to 2 to the power y, and we're able to write it as y is equal to log base 2x, just know that you will be expected to move from that and take it back to what it used to be. So now, how did you get there? You need to know how did you get there so that you can be able to go back, because it is important to know that there is moving forward and then actually going back once more. So that base that goes with log, I just want to make an emphasis on that. That base that goes with log, which is the 2. The 2 was the base to the exponent on the original equation. The 2 was the base to the exponent on the original equation. So always remember that. And that x there that you have as the subject of the formula is the one that is now next to you as the base of this log. And the y that is now the subject of the formula was the y that was your exponent when you were still in the exponential form. So never miss that, because when it comes to creating an inverse and doing calculations on inverse, an equation is sometimes given as y is equal to log 2 and x. So now you are expected to do your calculations. You will not be able to solve for x in this form. It's going to be difficult for you to solve for x in this form. It is quite simpler when you are able to take the equation back to its exponential form. So pay attention. It's y is equal to log base 2. This base is the base of the y that is the subject of the formula. So you have 2 to the power y is equal to x. Always remember that. You have 2 to the power y is equal to x because the 2 is the base of the log, meaning that the 2 was the base of the exponent. Now, translation. I had a question about translation. Someone asked about translation. Translation goes back to grade 9, if I'm not mistaken. In your Cartesian plane, we always say that the first quadrant is your point of origin. And in your Cartesian plane, you can move as much as you want on the 4 quadrants. But there are 2 things that I want us to remember. Translation has got the shifts in the axis to the left and to the right, up and down. And then translation has got reflection. Reflection is done on the point of origin, whereby X is positive and Y is positive. That is the first quadrant. So if we're about to do reflection on the first quadrant, we've got 2 mirrors, the one that is on the X-axis and the one that is on the Y-axis. So whenever we say that a point has been reflected in the Y-axis, I want you to imagine a Cartesian plane, that I am in the origin and I am moving along the Y-axis. If I am moving along the Y-axis, that means I am moving from the first quadrant to the 4th quadrant, to the 2nd quadrant. So in the 2nd quadrant, what are the coordinates of X and Y there? What are the signs of the coordinates of X and Y there? X in the 2nd quadrant is negative, but Y is positive. That is why we say that a reflection in the Y-axis changes the sign of the X value only. Again, when I'm reflecting a point from the origin along the line Y is equal to 0, because that's another thing that they get to say. Reflection along the line Y is equal to 0. They don't want to say reflection in the X-axis, but they will just say it's a reflection in the line Y is equal to 0. So when we're doing a reflection in the line Y is equal to 0, it means that you are moving from the first quadrant down to the 4th quadrant. In the 4th quadrant, what is happening? The value of Y there is negative and the value of X is positive. That is why we say reflection in the X-axis changes the sign of Y. Now, here's a catch. Changing the sign of Y, what is happening? Y is always the subject of the formula in a function. So here you have Y is equal to 2x squared plus 3x minus 4. I'm making an example. So now they're saying that the translation happened to create the graph of h of x, and h of x has these rules. It was reflected in the x-axis. It means that the value of y must be multiplied by negative. Where is the value of y? That's what you're asking yourself. The whole equation is y, because it said f of x, and f of x is a functional notation, and a functional notation denotes the value of y. So now you have y is equal to 2x squared plus 3x minus 4. So instead of finding the value of y or whatever, simply take that whole equation and multiply it by a negative sign. Put it inside the bracket and have a negative sign outside to show that this is a reflection in the x-axis. So Tina, when we get to mark that question, all we are looking for is the negative sign that denotes that this person has reflected this equation in the x-axis. Thank you so much, Putluvuko. Can we go to the next question? I hope our financial maths. What was about the financial maths? Out of all my learners, one person got this right. Even the memorandum, apparently, when they saw the memo, the learner came to me and said, "Did you see that the memo was wrong?" And I was like, okay, I did not pay attention, but I know that you're correct. So here's the thing there. It said 900 Rand has been deposited into this account for 10 years. And then it was increased to 1,300 for the next 5 years. One thing that the person who wrote the memo, on the memo discussions, we did have an errata that actually showed the mistakes that they made. So what happened there was the 900 Rand that was invested for 10 years then stayed for 5 more years. We do as asina mali hleli phansi kwe-trust. Phansi kwe-trust, there is no interest. If ever I am putting my money under the mattress, I am not going to get any interest. if I left 200 Rand, even next day, it will be 200 Rands. But if I put my money in a financial institution, there's no way that I could leave 200 Rand this year and I come back next day, still 200 Rands. So whenever in financial maths, money is untouched, it's just staying there with the interest, with the number of terms, and you know the value that is sitting there, that money generates interest. So what they missed was the 900 rands in that period of 5 years was now generating interest in a compound interest. And then the 1,300 proceeded for the 5 years with no hiccups. Then at the end, they had to add them up together and give us a total. Now in 7.3.1, the outstanding balance, when we are calculating the outstanding balance, learners tend to miss this. Because the outstanding balance, when we teach it, we usually say that it's compound interest minus the future value. And remember, you will be told to calculate an outstanding balance after a certain period. The investment was for 250, you were going to make 250 payments, let me just say. You're about to make 250 payments, but now the question says, calculate the outstanding balance after the 175th payment. After the 175th payment, calculate the outstanding balance. The compound interest part is going to use that 250, the original N value of N, but then your future value is not going to use 250. It's going to use 175. But if ever a learner is using the present value formula, in that present value formula, your N is going to be 250 minus 175. And you want to know what is the present value in that remaining term after you have been paying for 175 times. So learners tend to miss this. They use the present formula, but the value of N is something else. The value of N is that original value, number of terms that you had, as well as you subtract the ones now that you were given. Getting to 7.3.2, missed payments. I've mentioned this in 7.2. That in financial maths, asinayo imali ehleli phansi kwetrust. We don't have money that is just lying under the rock. When a person missed payments, they will tell us for how long. So, and that statement, it said that the person did not make payments for 4 or missed 4 payments, if I am doing my calculations right. What you do, you calculate your present value if it was needing a present value, because it's a loan. A missed payment means that it's a loan. You calculate your present value up until that particular period. Then you read the statement. How many months did this person miss? This person missed 4 months. Then that means the value that you got there as your present value, you now need to calculate the compound interest of that value for 4 months. Because if I am not making payments towards my house, towards my car, it means that I have to, the money that I am not making payments on is actually generating interest after. So we need to pay attention to that. Learners get to lose a lot of marks because they simply forget the compound interest. That money does not just stay. When the money is sitting there doing nothing, it means that it's generating interest. I would make a reference. It's almost about to be festive season. Car dealership will start advertising cars and saying that you take the car in November, your first payment will be in March. So that means December, January, February, 3 months, yay, you are celebrating. On those 3 months that you are not making payments, the car that you bought is no longer 250,000 when you start making payments. It's 200 and something thousand compound interest for the 3 months that you haven't been making your payments. So any gap that they give you, that, okay, no, take a gap, relax, don't tatazela. The minute you do not pay, you are giving them interest because they know that it's not just sitting there every night, it's generating an income for them. Next slide, please. This was a nice question. There's nothing much that I could say here. Deriving from the first principle, careless learners missed the formula. The formula is there on the formula sheet. Do not forget that it's supposed to be on the value of x, you just put it in x plus h. Whatever the equation was looking like, you're supposed to put, x plus h, then you proceed with your calculations. Rules of differentiation, whenever you see a Z, your first mark is changing that square root into a radical form. Whenever you see root x, always know that having x to the power 1/2 is going to give you a mark. And in the rules of differentiation, we do not care about a positive exponent. We do not care about you leaving your answer with a positive exponent as long as you've done the proper differentiation. Number 3, on the rules of differentiation, when you see something on the denominator, pay attention. You have got 2x on the denominator. Do not take 2x up to the numerator. 2 is, as we don't work with the 2. We don't need the 2. The 2 is only going to be affected by the exponent when we're dropping down the exponent and multiplying to the coefficient. So do not take 2. 2 remains there in the denominator. Take your x and take it up. X will be there as -1. Then you simply -1 times, then it's going to affect the 2. Don't take the 2. So always remember that. We had an equation here that said x cubed minus 5x squared all over x cubed. So what you want, once you see that your fraction has got one denominator, spread the fraction to your numerators, separate. You should have had x cubed over x cubed minus 5x squared over x cubed and start applying your laws of exponents. Then differentiation comes after. In question 8.3, it said something about the maximum. In grade 12, whenever we see the word maximum, we always think, okay, it's optimization. So once you are expected to optimize, you optimize through deriving. So you either determine the axis of symmetry or you calculate using the derivatives, whereby you just use the rules of differentiation. So in that question, you were expected, because you were given negative x cubed minus 3x squared and what. So you had to derive, because it said we want the maximum value of x. We want the maximum value whereby x will be equal to whatnot and whatnot. So all you had to do is to derive negative 3x squared minus 6x. Then once again, derive, because it's a straight line that we're referring to. You now have negative 6x squared minus 6. Then you solve for x from there, and then you substitute that value of x in your original equation to get the maximum value that we're talking about. Next slide. Cubic function. And the cubic function, sometimes you are given the cubic function with all the variables. Polynomial yako iphelele. You have your x cubed plus 2x squared minus 3x plus 5. So meaning that everything is there. But in this time, it was not the case. You were given the stationary points. And you were given an equation with 2 unknowns. You already had the value of a. And you were shown the graph and the intercept with the axis. Some learners use the intercept with the axis to determine the value of D and the value of B. Some learners used the stationary points, because if ever you have got 2 unknowns in your equations, always remember that the first one is going for you need to solve simultaneously. That's the first thing you must remember. You will be solving simultaneously, and solving simultaneously means that you have to create two equations. So on the two equations that you're going to create, how are you going to create the two equations? That's what we need to talk about. You have the stationary points. How do I get the stationary points? In stationary points, you get them through deriving. You need to use the rules of differentiation, whereby you now have f of prime of x. Stationary points are f of prime of x is equal to 0. So that value of x that you have there, you need to first derive on this original equation that has got unknowns. Derive from there and then substitute the value of x, and y will be equal to 0 there. Then you solve and create an equation 1. Now, on those stationary points, you are also given the value of y. What do I do with the value of y? How did you get the value of y to begin with? So the value of y, you had to substitute that value of x you got when you are doing the stationary points, but substitute it where? On the original equation. That is where you will get your second equation. Y will be equal to the value of the stationary point, and the x will also be equal to the value of the stationary point on the original equation. Now you have got your second equation. Now make the subject of the formula and start your subtraction. See a good question.
Somebody does not unmute by error. FGLers, please make sure your microphones are on mute. Please, we'll do a Q&A after this paper 1. So all the questions, Kungwayo, I see your question. If there's any other questions, you can put them on the chat, or can you put your hand up once Ms. Nobetsiki is done with this paper 1.
And always remember that a stationary point came from f of prime of x. It's something that I've just said. F of prime of x is equal to 0. That means you have to do those substitutions there where x is equal to, where y is equal to 0. And the second one, y is not going to be equal to 0 because you will have the value of y as the stationary point. And next slide. We're almost done with paper 1, optimization. This was a very nice optimization. I've got about 48 learners, and I think probably 3 did not get this question, to show that it was easy. It was a rate of change, unlike the ones that we actually use the measurements. It was the rate of change. So here you were given the formula that we're talking about, the number of scripts and the time it will take to mark those scripts. So all of that was given in a formula. So now a question says, how many scripts will a person have marked in 3 days or in day 3? T, they have already told you that T stands for time taken. So all you have to do is go back to the formula and substitute the value of T, which is equal to 3, and get your answer. The second question says maximum value, a maximum number of scripts. Calculate the maximum number of scripts that this person would mark. Maximum means we are deriving from the first principle. You just derive. That's one thing that you do. We use the rules of differentiation, and then we solve for x. Then we take that value of x and we substitute it on the original equation, and we get our answer. Number 3, the learners did not quite understand that question. That's one thing I could say. Learners did not quite understand that question. Because the question says the person is supposed to mark 500 scripts in 10 days. Did this person meet the quota? So all you had to do, what they did was they substituted 10 in the original equation, that S10, and the answer was 0. And they said that, no, the person did not meet the quota because the answer was 0, which was not the answer. The answer was supposed to be, the person should have had the number of scripts for 1 day, day 2, day 3, day 4, day 6, day 7, day 8, day 9, up to day 10. And the answer was 495. The person got 495 scripts that they marked in 10 days, to show that if ever this person was supposed to mark 500 scripts in that 10 days, the person did not meet the quota. Next question, next slide. Ooh, Oh, Jesus Christ. Hey, we're still trying to find ways and solutions to make learners understand probability. It's a struggle, but you guys try and you fight. The first part of probability is always grade 10 and grade 11. We're talking about the types of events. We're doing Venn diagrams, probability of not A or B. Apparently, there is a presentation for grade 11 after this, and grade 10. Do sneak in on the grade 10s because it's quite clear that probability you do in question 10.1 is quite clear in grade 10. The counting principles or the contingency table before that, the contingency tables, we use contingency tables as well as tree diagrams to prove independent events. Probability of A and B is probability of A times probability of B. And if that does not happen, it means that the two events are not independent. So we had a question that required us to narrate a statement like that. Probability of A and B gave us 0.1, I think. And then probability of A times probability of B gave us 0.7. So it means that they were not the same, meaning that those two events were not independent, but were dependent. Coming to the counting principles, it was quite a difficult question. Difficult in the sense that there were a lot of technicalities in it, because it said that you are to create this KZN registration plate, and in that registration plate, it's obvious that you have to end it with ZN, and it has got 2 letters at the beginning, and then 2 digits after, followed by another 2 letters. Now, on the alphabets that we have, a lot of my learners missed the part where it said, you are not supposed to include the vowels. It's very important to read the restrictions when it comes to the counting principles. The restrictions are there and they will just mess up your calculations. You are not supposed to include the vowels, but they included the vowels. We have got composite numbers and then we have got factors of 4. Firstly, they struggled with composite numbers, which is something that is taught in grade 8. So they struggled with composite numbers. Composite numbers are the opposite of your prime numbers. And then they struggled with knowing the fact that it said nothing must be repeated. So now there is a lot that needs to happen there because 4 is a factor and 4 is a composite number. So in that registration plate, you cannot have 4 twice, but there has to be an arrangement that accommodates 4 as a factor and 4 as a composite number. So that's why we had to add again the other values so that the sequence works out. So there was a lot of restrictions on that counting principle question that was actually given. So one thing I can tell you when it comes to the counting principles is pay attention to the restrictions. When they say they do not want this, it means that it will affect your calculations at the end. And number 2, if it says probability, it means that you need to divide by the total possibilities. Because the minute you do not divide, it means that you are simply making an arrangement in which that is not the answer. You could get a mark just for saying divide by the total possibilities. So learners got 1 mark on that. Again, it was said that we wanted the first digits to be all the letters that are before F, if not G. All the letters that are before F, if not G. So we had to count how many letters are before F. After doing that, we now had to subtract the vowels. So there were a lot of restrictions. So when we're answering that question, that last question of probability, we need to pay attention to the restrictions. Thank you so much, Woody. Can we go to the next slide? Questions. Okay, I feel like I've touched on the part Emyoli said into ayifumane i-difficult ngicela ubuye umva. The questions that I found difficult on the trial exams are as follows: the inverse functions. The only thing that could be changing an equation from the log form to the exponential form. I feel like I've touched on that. I did say that you must know how did you get to the logarithm form, so that if ever you know that the 2 that I have as a base of a log, where did it come from? It was first the base of an exponent. What happened to the exponent? The exponent became the subject of the formula. So now you will know that log base 2 is going to be 2 to the exponent y, and all of that will be equal to x. The counting principles, I've touched on the counting principles. Pay attention to the restrictions. If it says 4 letters, if it says 4-digit code, you need to know that if I'm creating a 4-digit code out of 0 to 9 digits, it means that you will not have, they say that the digits are to be repeated. You do not have 10 to the power of 10, but rather you have 10 times 10 times 10 times 10, because you only need a 4-digit code. Next slide, Putin. We were given this function. I would like clearance on how to solve problems of the gradient at any point. Problems of the gradient at any point. Quick cubic function. When we're talking about the gradient, always remember that we're referring to a slope. Create slopes on your tangents. Remember, a tangent touches whatever it touches, be it a circle, be it a function, it touches it once and outside. So in your cubic functions, your cubic function is in the form of a flowing S, if I could say, or a flowing M or whatever, but just create lines that flow with your function. And if ever it's a negative slope, you know that the gradient there is negative. If it's a positive slope, you know that the gradient there is positive. How is it negative? Is also get left, right. How is it negative? Is also get right, left. So those are the strategies on how you can deal with the gradients on a cubic function. Next slide, but determining the number of payments in finance. The number of payments you need to be, you just need to be manual about it. Let me just say, if ever they said it started on November 2005, 1st of November 2005, and it ended on the 1st of December 2030, you need to first know that from November to December, it's 1 month here. So if ever it is 1 month here, that means the following ones are 12, 12, 12, 12, 12, 12, 12, up until you get to the last year. So that is how we get to do the finance. Otherwise, I've spoken about all of these probability and counting principles, optimization, and all of that. I think we have touched on them. Thank you so much, guys. I believe that you can just go and drink some water. Just quickly go through paper 2.